DOH, ich mich Andy. I'm the developer of PÚCA DSP, and today we're going to have a quick look at getting started programming using VS Code and PlatformIO IDE. So I'm using a Linux machine. First thing we're going to do is open a terminal window and run the update command. Next, if we run this command, it'll configure our Python 3 virtual environment, which is needed for VS Code. I'm not going to install it just right now, as I've already previously configured this. After this, we can move on to installing VS Code. I'll put a link in the description to the web page that we're going to use that runs through a few easy steps to install VS Code. Once it's installed, we can go ahead and type in code from the terminal window, and that'll run the VS Code. Other thing to look at just before we get started with our Blink example is we want to make sure we can access the USB ports. In order to do that, we want to add your username to the dialout group. So if we type in this command, add your username, plug in our PÚCA DSP, let's check the status of USB 0. Now we can see our device is there and the group ID is given us as dialout. If you're having problems at this stage, you might want to check your PySerial installation. Let's jump into VS Code now. So if we go into this toolbar on the left, click into extensions, and let's type PlatformIO. You can see it there that it's already installed in this version of code because I installed it earlier, but you can just click install in here to install the extension. Let's take a look at configuring a project and compiling and flashing it to the board. We'll go to the home page and start a new project. So this is what your welcome screen will look like in VS Code. Open the new project wizard, give a name for your project, select the board. We're going to select the Expressive ESP32 dev module. And framework, Arduino framework. So click finish. So we'll see our projects open here on the left in the workspace. What we're going to do is we'll have a look at the PlatformIO.ini file. So this is the configuration file for your project. So we can add additional information in here that will help us to program our device. So let's set the CPU frequency. So we go to board build.f_CPU. Let's set the flash size and the partition scheme. So 4 megabytes is the size of the flash on the original edition. I'll add a link in the description as well to the various different partitions that you could include as part of your project. For this example, we'll go with minimum spiffs. And let's set the flash mode as DIO. So you could alternatively set it QIO, which is a bit faster, but if you're having some problems with upload, maybe DIO might be more reliable. If you're using the Strawberry Edition board with the 16 megabyte flash, we need to configure a different flash size for 16 megabytes. So board build, flash size, 16 megabytes. And also additionally, the Strawberry Edition board doesn't have any additional PS RAM, which is on the original edition. So we'll add a build on flag. And what this will do is allow us to bypass the initialization of the PS RAM. And next we can add some serial monitor options. So let's set the monitor speed, pick a baud rate for the serial monitor. And let's set our upload port. So we checked earlier in terminal that our device was on USB 0, so we can see if we add USB 0 here, PlatformIO recognizes the CP2102 and USB 2 ARC bridge. Lastly, we can configure a couple of debug options. I'll go for build type, debug, and similar to the build on flag, we're going to add a build flag this time to set the debug level as local. So next, let's have a look at our main.cpp file. And this is where we'll add our code that we want the program to execute. So there's an onboard LED on PÚCA DSP, which is routed to pin 5 on the ESP32. So define the LED firstly. And under setup, we'll start our serial communications. So we'll begin and specify the baud rate. And we'll set the pin mode for the LED to output. Once our program is run and set up, it'll go straight into our loop, the main program loop, and is where we'll execute our blink. So we'll write a digital high, turn on the LED. We'll optionally add a print in the serial monitor, so we can check that also. Wait for a second. And then we'll write our LED low. Which will turn off the LED. Optionally add a comment as well in the serial monitor. And we wait for another second. So that's it. So we're nearly ready to compile our codes. First of all, what we'll do is just check our configuration file again, and we'll see we have the flash size duplicated, so depending on which board version we're using. Comment out Strawberry Edition because I have an original edition board here just at the minute. Hit build on the bottom taskbar, and VS Code will build our project. So we'll see that this project is built successfully. And it gives us our memory usage. If we scroll up a little bit, we'll see which version of Arduino ESP32 is being used. In our configuration file, we can use this line to set different versions of Arduino ESP32. We can also check the tool chains, which using the ESP tool version 4.4. And we can confirm that the tool chain is the Extensa ESP32 compiler. So let's go ahead and flash it to the device. So we go over to the menu on the left, the PIO menu, and click Upload and Monitor. And this will flash our program to the device and then run the serial monitor in monitor mode. So we can see here that the program is flashed and our LED is blinking. And that's it for getting started. So in the next video, we'll have a quick look at the audio codec on PÚCA DSP.